Hello and welcome back to Cracking the Cryptic and an intriguing puzzle from Jessica Shaham today. Now, we have released our second episode of the podcast on YouTube today, so that is available on our YouTube channel. You may have seen it already, you may have listened to it already. It's obviously an audio medium and will be going up onto the various podcast outlets as they accept it, basically, from now on. So we'll let you know when that's up in those places. And that will join our Arrow Sudoku app, which has joined our stable of apps that are all available in Steam for Android and for iPhone on the App Store. So that is out. That has been out for a little while. It is garnering rave reviews. We're not surprised because some of the constructors involved are fantastic. If you like Arrow Sudoku, that is for you. Now, also, we got sent an email from some people on Discord who have put out an appeal and somehow put together, we had no word of this, a virtually 60-page and 60-puzzle document of people's cracking the cryptic journeys of their kind of experiences of the channel and of setting Sudoku. And it's really quite touching. I've read about 10 of the entries so far. I haven't tried to solve any of the puzzles yet. I will do that in due course. But it's really thrilling. I'm absolutely warmed by that document, I will say. We will find a way of bringing that to you in due course. I mean, fairly soon. Also, of course, loads going on Patreon. We have a crossword solve lately, all sorts of stuff that's gone up during the month. And we will be getting to the beginning of a new month fairly soon and bringing you some more puzzles to try. And obviously there's so much going on in Discord all the time that we can't keep up with it. There's no doubt about that. So anyway, I mean, tons going on. And 2 puzzles a day on the channel, and today's that I'm doing is Blast Off by Jessica Shaham. So you are not allowed to reinterpret the picture in this grid of the thermos. It is a rocket, and that's official because the title is Blast Off. I don't know, Jessica may well be more up on astrophysics than I am and know if there's some launch going on, but I love the shape anyway. It's virtually symmetrical. Obviously, it can't be... No, I guess the little killer clues stop it being that, as well as this vicious little 2-cell thermo, which I look forward to tackling soon. Anyway, the normal thermo and little killer rules apply. So if you know those, skip the next minute while I explain that, as well as normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. We have thermo rules, which means that along thermos, digits must increase all the way from the bulb to the tip. This sort of bulb is the tip to 2 different thermos, 1 there and 1 there. And then we have these little killer clues which add up the sum of the diagonals. Now those can include repeated digits, unlike killer cages. So it's a significant difference between killer and little killer. And just before I start, I will comment on the fact 1 or 2 people getting actually angry yesterday at us missing obvious deductions. I'm afraid these are human solves. These are first-time solves of puzzles that we haven't seen before, and we are human, so we are going to miss things that you can see from time to time. And I think the idea that we're always doing far too complicated logic and missing obvious things, that just relies on whether you happen to have spotted something that's obvious. If we haven't spotted it, it's not because we're away in the clouds. It's because we just haven't looked at that particular row, column, or box. You know, there are at least 3 dimensions you have to be studying everything in all the time. Anyway, not to worry. Let's crack on with this. Let's get cracking and see how we go. So, well... no, I was about to pencil mark the thermos, but I've spotted this first. This diagonal says it's 13. Now, within 1 box, you have to have 3 different digits. 1, 2, 3 is the minimum. So the absolute minimum here is 12. 1, 2, 3, followed by 1, 2, 3 would give 12. So there's 1 degree of freedom from that. So one of the 3s can become a 4. But 1 and 2 must appear in both of those boxes on this diagonal. Actually, that has implications for this diagonal because 1 and 2 cannot be in either of those cells. They have a minimum of 3, but one of them can't be 3 because in one of these cases there will be a 1, 2, 3. I don't know whether it's in box 2 or box 4, but in one case there'll be a minimum of 4 there. So those have to be 3 and 4. These have a maximum of 6, and that's not quite what I was looking for. I guess that means there are 3 degrees of freedom because they have a minimum of 3. So one of these can be a 7 if we had a 1, 2, 3 in the other cells. Yeah, and that's not everything I wanted to learn. Okay, let's start pencil marking the 5-cell thermos, of which there seem to be 3. Oh, actually, maybe I'll have a look at this 38, because I've just seen this 38 diagonal hits those 2 cells. They have a maximum of 11, being 7 and 4. These have a maximum of 24, being 9, 8, 7. Oh, and that would get us up to 35. So this is a minimum of 3. That's not the information I wanted. Maybe this is better. 70, yes, this is much better. This 30, that has a maximum of 4, and I think that's also its minimum for this 30 as well. So 9, 8 there is 17, plus 9 there is 26, plus 4 there is 30. That must be the way it is. That 4 removes the degree of freedom all the way along here. So we now have a 1, 2 pair to go with it, and a 1, 2, 3 pair there. And suddenly we are cooking with a bit. We're cooking with gas, that's the phrase. Now, that can't be a 3 anymore. This can't be a 4. I don't think we can do much more with that 13 diagonal, but maybe this 38. Now, this is 8, 7, 6 now as a maximum. That's 21. Maxima here, 7 is 28. 2 is 30. This has to be 8 or 9. There's only 1 degree of freedom from 8, 7, 6. So we've got to use the 8 and the 7 in those cells. This can't be less than 6 because of only 1 degree of freedom there. And that's using up lots of degrees of freedom here. Now, 6 and 4 would be the minimum. Yes, it's done it. It's used all the degrees of freedom here, hasn't it? Yes, because this is in the box where it couldn't be the 3. Yes, that's great. So 6 there, 4 here. Haven't had to pencil mark my thermos at all. And I've got a 1, 2 pair there, which matches the 1, 2 pair here. This is now 6, 7, and 8. The degree of freedom disappeared when that became a 6 instead of a 7. So this is a 9. Let me just check the maths in a moment. So 21, 30, 36, that has to be a 2. So actually those are sorry, I'm in the wrong mode. 2, 1, 2, 1. Those are all unwound as well. And now we know this can't be a 1, that can't be a 2. This can't be an 8. And look, those little killer diagonals have beautifully, I've only just noticed they kind of form the arrow, an arrow pointing the way the rocket is going up. So that's very well done. That's really elegant. Right, now this cell sees 1, 2, 4, 6, 9, and 8. So it's 3, 5, or 7. Well, we know it's not 3 because of its position on the thermo. We can also quickly work out it's not 5 because that would have to run down this thermo 4, 3, 2, 1. I emphasize the 2 there because that would clash with that 2. So we must have a 7 at the end of this. And then we can go down skipping 2 with 1 degree of freedom in each cell. I think that must be right. And then these 3 are going to be 3, 5, and 8 in some order. Right, and that wasn't quite as conclusive as I was expecting. So 9 in this bottom box, no, 9 in the central column goes in the bottom box in one of those 2. So one of these 2 is 9. This can't be 9. Yeah, we're going to pencil mark it now. 8765 there. 7654, 6543, 5432, 4321. Those are the only possible configurations. I've basically finished with the little killer clues. I mean, as long as I remember that these are sets of 3, they're done. Right, how do we move on from here? Shall I? Yeah, I'll pencil mark this one as well, because it's the same number of degrees of freedom as it can't begin with a 1. It's kind of the opposite way round. The other 5 cell thermo couldn't end in a 9. So what do we learn about this? 1, I guess, in this central box can't be in any of those cells, so it's in one of those 2. So then it's in one of these 3 along with 9. That kind of runs a bit dry at that point. Wow, we haven't got... I mean, it struck me when I looked at this opening grid that there just wasn't a lot of information provided. And I still think that, even now. 9 and 9, I suppose we can put 9 in one of those 2 cells. This can't be 6 or 7, because 6, 7, 8 are used up here. So that has quite a few ramifications dropping down to the beginning of this thermo. Oh no, yeah, I've deleted the wrong date. So wrong data. So 4, 5, 3 or 4, 2 or 3, 1 or 2. That must be right. It doesn't really resolve much. I'm not going to pencil mark this small one, even though this can't be a 9. Tricky to move forward. Surely not this. Well, I mean, it has to begin with 3, 5, 7 or 8 now and end with 5, 7, 8 or 9, but that's not very telling. I suppose one of those 2 has to be a 9. One of these 3 has to be a 2 and a 1 also. Am I meant to be able to use these bulbs? It doesn't look likely. They can't be 1s because of where 1 is positioned, but their thermos are so small it just doesn't seem to be helpful. Maybe it's this pattern here of 9, 8, 7, 6 and 5, 4. So whatever this is, which can't be in those cells, must be in one of these. I don't know how to use that either. So, yeah, decent progress so far, but a bit of a sticking point here. And I'm not sure how we're meant to find some information to move past it. Right, these can't be the same, maybe. Is that important? This can't be a 3 because it would put a 2 here and break this cell. So we can get rid of 3 from that. That means we can take out 4 there and 5 there. That reduces the flow a little. But not very much. 1, 2, 3, 4, 6 or 7. These are nothing like a triple. Even in this row where we have 5 pencil marked cells, admittedly none of them are 9, but that just means 9's in one of those 2 places. That's not very relevant to us, I don't think. What's going on here, folks? If that was a 3, this would go 6, 5, 4, 1. Then we'd have 9, 8 here. I don't know how to use that. If 3 was down here, this would be 3, 1, 9. Then we'd have to go 4, 5, 6. That would be an 8. Maybe this can never be a 5. If that was 5, we'd go 6, 4, 3, 1. No, this would be 9, 8. I don't see quite... And if this is 8, that leaves any number omittable from this thermo. Okay, I'm probably looking at the wrong bits of this puzzle now. Let's have a think. 2. 2 can't... Okay, where does 2 go in the middle row? That's a nicer question. Because it can't go in those cells, because 2 must be in one of those two. So 2 is over here in one of these two. The same's true, is it, of 8? No, because 8 can be there. So it's a special for 2. How can I use that? 2 has to be in a corner in this middle box. Just like 1, 6, 7, 8, 9. I really need to find a way to disambiguate these numbers. I suppose if this was 2, then we'd know this went 5, 4, 3, 1. That would have to be 8. 6, 9, 7. Wow, it does force a lot. 7, 1, 2. 4, 6. It forces a lot, but not conclusively. So it's difficult for that to be a 2, but clearly not impossible. Wow, okay, come on. Let's have another think. Do these little offshoot spurs of the rocket tell me anything? I guess they tell me 1 isn't on a thermo down in this box, but that feels like a very minor deduction. If this was 5, that would be quite powerful. 5, 6, 7, 8. Have a 1 here. This would be 2. That would be 9. Okay, so that's not possible, because that would also be 9 if this went 5, 6, 7, 8. So that's not a 5. Which is a tiny deduction. Yeah, but maybe it is about cells where things cross. So here, this is 3, 4, 5, or 6 based on what's in the row. Now that's almost beginning to form some sort of quadruple or triple again here. If that was 3, 4, or 5, that would form a triple. And this would be 2 and 1. That would be a 7. That would be all that was left. And this doesn't work. If this was 3, 4, or 5, my goodness, this is slightly complicated. I think this is right, though. If that was 3, 4, or 5, we'd have a triple of 3, 4, and 5. Then we'd go 2 and 1 down there. This would be a naked single 7. And these two would have to be 6 and 8, but they can't be because 6, 8, 7 runs here. So that can't be 3, 4, or 5, and therefore must be 6. Now, there may be some much easier way of seeing that, but that's how I've seen it. That can't be 6 now. Now, does a similar... That's 3 or 5, and 3, 4, or 5 here. Does a similar thing operate somehow here? Not so... Oh, yes, if it was 3 or 4, we'd have a 2, 3, 4 triple, which would... What would that do? It wouldn't do as much, because this doesn't... It doesn't force this. So maybe there's more to see here. This can't be 7, 6, or 8, or 9. So it is 1, 2, 3, or 5. Okay, 1, 2, 3, 4, or 5. Those are the cells, the digits it can be. And that forms a triple, a quintuple rather, down here. So that is 7 or 8, not 1 or 2. So the 1, 2, which have to be up here, are a pair. A naked pair up there. Oh, that can't be an 8 because there's an 8 in the box. Wake up. 7 there, 8 there. See, I'm allowed to think I'm a numpty. 7 in one of those. 3, 5, 8, or 9 here. Goodness me, a quintuple. Right. So this can't be a 5, or we'd have the same problem here. 1, 4, 1, 2, 3, 4, that would be a 5. Ooh, and this is nearly a triple. Those are from 3, 4, and 5. So they are forming a quadruple. Or put another way, 6 and 7 have to be a pair over here, which is the slightly simpler way of seeing that. I still think column 3 has the symmetry to provide me with something interesting, but I don't know how to isolate this down. Maybe I should be concentrating on something like where 9 or 2 can go. Yes, 2. No, not 2. 2 can still go there or there. I was pleased to see it couldn't go there. 9, though, can go there or there. And I don't know which. Oh, goodness me. Okay, this is surprisingly tricky, and I'm certainly not done yet. 6 and 1. What can this be? 4, 1, 2, 3. Maybe I need to think about the middle row again. We've got 2 over here. Ah, yes. Where do 1, 2, and 3 go in this row? That's a really interesting question. Because one of them can go here, but these two cannot be 1, 2, or 3 because they're a triple in this box. So one can go there, one must go here, and one must go here. So that's 1, 2, or 3. This one is as well. Now 5 and 4 in this column can be placed. This is the only place for 5. That's the only place for 4. Oh, and they're not reading across to anything. Curses. Right, 8, 9, 5. Don't know what to do there. 8 is in one of these 3 cells. That is the minimalist. The most minimal conclusion possible. 4, 2, 3, 1. Maybe I can eliminate this further. Or maybe I can use this 1, 2, 3 triple. Yes, where does 4 go in the row? I certainly can. 4 has to be here. I haven't quite got a 6, 7, 8, 9 quintuple, but I've got an effective one because one of these must be that as well. So that gives me 4 there. Now I can run that down to the bulb of this thermo. 3 and 1. That can't be a 3. So 3 in the top row is now in one of those 2 cells, and that's really nice for box 1 because 3 can't be in those, and I can fill them in. 5 there, 4 there, 3 goes over here. That's a 4, 5 pair, so we can't have a 5 in box 2 in one of those positions. That becomes a 5. Ooh, okay, so still don't quite know how they work out. Got a 1, 2 pair and a 4, 3 pair. Ah, this now can't be a 5. That's a 6. This has now become a 9, 8 pair. This is very clever. Right, we can take 4 off this thermo. That means that can't be 5, that can't be 6, that can't be 7. We're losing degrees of freedom all over the place. We've got a 2, 3 pair just spotted, so that can't be 3. Now there's an 8, 9 pair, so that is 3. Let's remove the pencil marks there, the corner marks, because they're just not really necessary now. Still got a 2, 3 pair. Then this must be from 5, 6, 7, 8, or 9. That's not very useful, is it? If it was a 9 or 8, I don't know. No, then it would form a pair with that, and we'd go 7, 6, 5. But it doesn't have to be that at all. Now 1, 2, 3, 4. Ooh, 6, 8, and 9. All looking at this cell, which is 5 or 7. 5 looking at that cell. Oh, 4, 4, and 4 across the middle. So 4 must go in there. That fixes the 5, 4 pair at the top. One of these is a 5 to go with the 8. The 8 being in there. Yes, that can't be 8. Hasn't been able to be 8 since we placed it. Now we've got a 1-2 pair in the column as well. So these are all from 5, 6, 7 and 8. But I can't use that as far as I can see. Still, it's information. Now let's have a look across the middle again. 4, we've got the 1, 2, 3 set. That can't be 5. So it is 6, 7, 8 or 9. Yes, where does 5 go across the middle? I should have followed up the question about where 4 went with the question about 5. It's got to be here. And that's fixing a lot of this thermo. 6, 7, 8, 9. We get a 9 at the top. That little planet that this was aiming at is or meteor or something, is a 3, 8. Wouldn't have guessed that. Right, 2 or 3 there. I am going to pencil mark this one now. 3, 4, 5, 6. No, not 6. 3, 4 or 5 there only. And then 5, 8 or 9 at the end of that thermo. Interesting. Don't know quite what that gives me. Now, that can't be 8. This is just because it's in the box. 5, 4, that's a 1, 2, 3, 5, looking at that cell. So that's a 7. So that's not a 7. It also can't be a 9. That is a 6. This is where 9 goes. Now that 6 looks straight across here. 7 there, 8 there. Still, that 1, 2, 3 that we started with is not resolved. That 7 fixes a 6 here. So now that is a 5, 7, 8 triple. So 6. This is a 9, 6 pair. I know that's not a 9 because of the thermo. I know it's not a 6 because of that 6. So this is 1, 2 or 3. Can't be 1 on that part of a thermo. So now we've got a 2, 3 pair and the 1 goes on the bulb. That's very pretty. 2, 3 pair looks across to here. So that can't be a 3. And that doesn't result. This can't be a 3 because we've had that for a while. 6 has fixed this pair. 8, 6, 2, 7, 9. Right, that is 3 or 5 by just ordinary Sudoku rules. This can't be a 1 either. Yeah, 1 and 1 there. Sorry, that could have placed a 1 there a while ago. Right, so 2, 3, 1, and I think these boxes 4 and 6 are fully done now. That 3 sorts out the 2, 3 on the thermos. That's a 1. We can do those at the top. That 3 has been available for ever since we pencil marked that 8, or filled that 8 in. That can't be a 1. 1 there, 7 there, and a 2, 5 pair in row 4. Oops, not there. 2, 5 there. So now we can use these tiny thermos perhaps down here. If I'm not, I'm just seeing what else I'm missing. 2, 3, 4, 5, quadruple there. So an 8, 9 pair. Easier seen in the column perhaps. That can't be 7. Right, we are going to use these. 2, 3 or 4. 4 or 5 there. 2, 3 or 5 there. And here, 1, 8, 4, 3, 9 gone. So 2, 5 or 6. 5 or 7 there. 2, 5 or 6 here. So what on earth is happening here? 8, 9 pair there. 4, 5 pair there. Good grief, thanks to the thermos. So that gives me 7 there, 8, which sorts out the triple. That 8 also sorts out the 9, 8 pair. That must let me place, doesn't. Must let me place 8. Yes, 8 in box 7 there. 9, that 9 gives me the 9, 6 pair. That takes 6 off the thermo bulb. Ooh, don't know what to do. 5, yeah, that 5's very helpful. 3 there, 2 there, 6 there. Now I can do the 2, 5 left up at the top of the rocket. 5 there. 4, 3, 2, and that must be a 4 and 5, and we have liftoff. There we go. What a brilliant puzzle. That really is so elegant, so little information, and yet it flowed together, and not in the same way at all. Like, there was a similarity in how these little killer clues worked, but then very different struts of the rocket, as it were. Really nice puzzle. I hope you had a go at that. That was very entertaining. Half hour of great fun. Thank you, as always, for watching us on the channel. We are delighted that you bothered to give us your time, and hope to see you again soon. Bye for now.